Okay, Nintendo, you had me going there for 13 months. I was getting really worried you were never going to update Mario Kart World, but you've done it. The drill and boomerang tours are actually so much fun. Oh, whoa, this is a new wave. This track is amazing. Look at these guys. These knockout tours are so good. However, I must say I'm very disappointed in you. It's taken so long to add 2 of them. What are you doing? At this rate, it'll be 2029 by the time we fill out this whole screen, and oh my god, I cannot wait that long. Just, what are you doing? That got me thinking, what are we missing out on by the game just not letting us play these ones, right? I was like, how hard can it really be to add more? So I did. In just 50 minutes, I added thousands of them. Literally any combination you could possibly want, which is, I don't know, roughly 500,000 times faster than you. I didn't rush my implementation either. We've got a nice UI to display everything, starting from any track and going randomly, starting anywhere random and ending where you want. Or even, you'll love this, having the start and end fixed, and you can have any random path between them. You know what, Nintendo, actually, because I'm such a nice guy, thank you, I'm going to give this whole method to you completely for free. And yeah, you can just take all this code, generate the rest of the tours, fill them in pretty much, well, this evening. I've just saved you 3 years. Boom, now you can put that time into making the new 3D Mario that you should have been doing for the past 10 years. Where is it? Seriously. I know, okay, 50 minutes might look a bit scary, but you know what? It's actually a really nice time. I'm going to fully explain the graph theory methods going on and how to make these new tours is actually really simple. So this is just a beginner guide from scratch that you or anyone else somehow watching this can use for your own learning and enjoy. Okay, Nintendo, love you very much. Please do this soon. Thank you, and happy coding. Hello everyone, thank you for being a bit curious on how you can generate your own completely random tours so you can experience everything that Mario Kart World has to offer. In this video, we're going to look at how we can define the actual Mario Kart world of how all the tracks connect to each other and represent this as a graph using Python. While doing this by accident, we're going to pick up a lot of really useful computer science knowledge, all while just messing about with some Mario Kart stuff. So I think this is going to be pretty fun. Okay, so we have a new Python project here, and we just have one file for the moment, Mario Kart World, MKW. And in this file, we're just going to put everything relating to Mario Kart World itself. And that's going to be the tracks that are in the game and how they connect together in the graph. Now bear with me, I know this is tutorial 101. To not do is to just make you copy paste loads of code, but trust me, you're going to want to just copy paste all this code because creating this graph is a nightmare. Okay, so the first thing we need to do is we just need to write down every single track in the game. And I went across from left to right, top to bottom, and just wrote down every single track I saw and gave each one a different ID, so a different number. So Crown City is track 22, Peach Stadium is number 17. These numbers don't mean anything, they also don't matter, as long as they're unique for each track. And this type of data structure that holds all these different options for a track, in Python is called an enum, so we need to include that as well. Okay, and just to quickly demonstrate why this is useful. Okay, so we can now go track dot, and then we can see we have this huge long list of all the different tracks. And we can then select one of these tracks, Whistle Stop Summit, and we can print it out and you can see, okay, track Whistle Stop Summit. So obviously nothing special so far, but this now just gives us a way to easily, in future, if I wanted to go from Whistle Stop Summit to, where do I want to go? Toad's Factory? Sure. Well then now I can just easily define them like this, and it's a really nice way of holding all the tracks. Now we have all these tracks, we need to actually make the graph that connects all of them together with all of their different races. So to start with, we're going to need a graph. Okay, so we're going to use the Network X library to define our graphs. And Network X is just the go-to library anytime you want to do something a bit more complicated with graphs and you just want a nice pre-built way of doing so. Okay, so just to sanity check everything, we can add every track in our list of tracks to the graph by just adding it as a node. And then we can use matplotlib, which is just the standard plotting library for Python, to put all of these nodes in a nice little arrangement around it. Obviously, none of them are connected together yet, but you can see this already starting to kind of take shape. We do this by creating a new matplotlib figure, and then we use NetworkX to draw this graph that we added all the nodes to, using some positional spring layout here. So for example, this is just how all the nodes are laid out, because you can imagine we could put these nodes literally anywhere and it would still be fine. There's no reason they have to be in a circle or in any configuration they'll end up in. And this is just one way of calculating those. Labels adds the names of the tracks, obviously the colors, the size, and arrows. If there were any edges, then this would show them. And then we just show that to the screen, which is very nice. Okay, so let's wrap this in a method so it just doesn't run every time. Okay, so we've deleted our little temporary adding to the graph here. Now let's do it properly. Okay, so I'm going to start out by just writing 3 little helper functions here, and let's explain what they all do. So we're adding a self edge. That is a 3-lap track in Mario Kart World, because not only can you go from where you currently are on your track to a different track, you can also loop around on the same track, which lets you do a 3-lap race of it in versus mode, which is essentially having an edge from itself to itself, just staying in the same place. Now we can also add a regular edge by just adding an edge from A to B, which are these two tracks here. And we can also add die edges, which are edges in both directions. So you can see this is a directed graph. So each edge is kind of like an arrow instead, so you can go from A to B, but not back to B to A. And that's what this one would say, because we're only adding the edge from A to B. But here, and most of the time, almost always in Mario Kart worlds, you can go from one track to the other, and you can go from that track back again. So we just want to add both of these edges at the same time without having to type it out manually. So I'm just going to have this little helper function for me. I'll point out there are some very specific cases where we can only have one direction. For example, one of them is Peach Stadium to Rainbow Road. You can't go from Rainbow Road back again. Okay, so now it's time to actually add all the tracks and the edges that are really existing in the game. And we can start by just defining where we're coming from, A, and adding a self edge to A. So this is just going to tell us that we can go from Acorn Heights to Acorn Heights, which we know we can do. Then, by going down the list in the game, we can see that Acorn Heights can go to Boo Cinema, Dandelion Depths, Mario Circuit, Toad's Factory, and Dry Bones Burnout. This is simply just going down that list and adding an edge in both directions, this die edge here, because you can go back again from each one of these. And if we show this, okay, perfect. We can see that if this was the whole game, we'd be done. So we have Acorn Heights. It can loop on itself and it can also go to any of these other places, which is fantastic. Now, I do warn you, we have to now do this for every track in the game, and this took me a very long time. So I would highly recommend you just copy and paste what I'm about to as well. Okay, so you can see we've now added ones for Bowser's Castle, Dry Bones Burnout, every single other track in the game. Okay, the only interesting ones that are different is Rainbow Road, which is just a complete dead end. Okay, also the one thing different with Peach Stadium is that it goes to Rainbow Road, but only in one direction. So we don't add the directed edge here both ways, we just add the one singular edge from a Peach Stadium to Rainbow Road. And I don't know if this is a bug or not, but for some reason, this is the only place in the game I can find it, Great Question Block Ruins goes to Koopa Troopa Beach, but Koopa Troopa Beach doesn't go back to Great Question Block Ruins. So we just need to add a singular direction here. We can't add the die edge because we're not going from Koopa Troopa Beach back again, which is really strange. Okay, and if we run this now, we'll see this massive convoluted graph here, but this is absolutely amazing. We can see perfect. Rainbow Road is separated out by itself. That's the only thing that's on its own, and it's coming from Peach Stadium. We can see all the tracks have their self loops, representing that we can do the 3 laps on them. And I can't confirm it, but this does look pretty good. We have Peach Stadium, Mario's Galleon, Sky High Sunday. Obviously, the arrangement isn't the same as it looks on the world of Mario Kart World, because there's no actual reason any of those have to be in those positions. And if you run this again, you'll see it's different every single time, because they could be anywhere as long as the abstract representation of what's connected to what is the same. This is kind of closer-ish. We have Bruce Cinema up here, Wario's Galleon, that's normally over on the other side. I think Sky High Sunday the same, so it's kind of mirrored here. But it's roughly the same. Yeah, Airship Fortress on the right. If you flip this around, it's actually pretty similar with Acorn Heights, especially at the top. So that's actually pretty good. Okay, so now we have this graph. What we want to do is create our tours, is to look through this graph and figure out all the random different ways we can go to and from different places. And that has nothing to do with Mario Kart World's graph itself, so we should do it in a different file. Okay, I've called this file tours. And we're just going to import the graph from Mario Kart World that it created that just represents the entire world here. And we're just going to show the graph in this file now instead, just so we can check that it still works, because we imported this graph correctly, and we did. You can see we can keep regenerating it and it's still completely fine. Okay, the first thing I want to do is just give G a better name. I think we can be a little bit more descriptive. And we can just rename it to World, because it's describing the world of the game. Okay, and just make sure we rename it here as well. Okay, so the most basic thing we want to do is be able to just say, okay, I want to play 4 races, but I don't care about anything else. Give me a random tour. So we input n, the number of races that we want, and it's going to give us the tour back that fits from that. Okay, so very simply, I'm just going to say that I want to get a random tour of length 4, and for now I'm just going to print out n just to make sure we're doing that correctly, and we are. We can see we're getting 4 here. We also have this tour so far variable, which is simply going to keep track of the tracks that we've actually got so far, which starts with none, and if it starts with nothing, then we need to just create a new tour. Okay, but what else could tour so far be? Because theoretically, let's say that I had 4 here, and I also gave it the tour that we have. Okay, so making sure that we're also importing our set of tracks that we actually have in the game from Mario Kart World as well, then just Theoretically, this tour can't exist, but let's just say that so far my tour was Toast Factory, Whistle Stop Summit, then Boost Cinema, then Desert Hills in this list here. Well then, because I only want 4 tracks, then this would be done, wouldn't it? Because tour so far would have a length of 4. So we need to check that if we've already finished, then we can just stop. Okay, so we're going to get the tour the list generates, and then we're going to print it out, and you can see that, okay, it's detected that this tour is finished because it has the correct length, and it's just going to show that back to us, which is great. But you'll see there's actually a little catch here, that going from Toad's Factory to Whistle Stop Summit, Whistle Stop Summit to Boost Cinema, and Boost Cinema to Desert Hills, that's actually only 3 races. It's not 4, even though we have 4 tracks, because we're only playing the intermissions, the edges between these 2 places. You can see there's only 3 of them. So if we want n races, 4 races, we actually need to have n plus 1 tracks. And if I would just run this now, you're going to see we get nothing because we don't have n plus 1 tracks. We're still missing one. And so we just return nothing because the tour isn't finished yet. Okay, so we can get rid of that because that was just a little demo. We just want to start completely from scratch with a random tour, so we don't want this to be anything yet. And now let's go about how we actually make it. Okay, so yeah, we know that we need to add a new track to our tour because we're not finished. And if we were finished, we would have returned here and we wouldn't get to this part of the code. Now, what can this new track be? Well, keep in mind that if we already have a track in our tour, then this next track has to follow on from that. But if it's the first track, then it can just be anything randomly, we don't care at all. Okay, so if this is the first track, we've got nothing so far. Then we're going to say that the tracks that we can possibly go to next is all of them. So we just grab all of the nodes from world, which represents all of the tracks that are in the graph. Okay, so if the length of the tour is not 0, we've already got a track there, which means we need to follow on from the previous one. Okay, and we can do this by looking at the world graph and getting the successors of the previous track. The successors of a node in a graph are all of the nodes that you can get to from it. So basically anything that has an arrow coming out. So for DK Spaceport, for example, its successors would be Whistle Stop Summit, Crown City, and Koopa Troopa Beach, because those are the ones that have an arrow pointing to it. Okay, and you can see that that is actually what we get exactly when we run the successors function, but it also includes DK Spaceport itself, which I forgot about, because obviously there's this loop around on itself, which is obviously pointing back to itself again. Okay, so we have all the next possible tracks that we can go to from wherever we are currently, and at this point we have a decision to make, because it's possible that one of the successors of these tracks is somewhere that we've already been. Now, what does that mean, for example? Well, let's say that we started at DK Spaceport, we went to Whistle Stop Summit. From Whistle Stop Summit, we went to Koopa Troopa Beach. And then from Koopa Troopa Beach, those successors also include DK Spaceport. So we could kind of cycle round in this big loop forever. Let's say I wanted a tour of length 6, then it could actually just be DK Spaceport, Whistle Stop Summit, and Koopa Troopa Beach repeated twice, which is not really very fun, but maybe you want that. Who knows? I am not me to judge. So let's add a settings option for whether or not you want repeated tracks. Okay, so this is very simply just going to be a flag here for allow repeat tracks in a new file called settings. And you might want repeated tracks because let's say you went from Whistle Stop Summit, you started there, went to Crown City, then Chocolate Mountain, Peach Stadium, back to Crown City. Now, although you're going back to Crown City, you're coming at it from a different direction, so you're playing a different race on this edge that connects between the 2 places. So it's a bit more complicated, and you really might actually want repeats. But for now, we're just going to default to false. Okay, so we need to import everything from the settings file. That's what this little asterisk means. Just get everything there. So currently, this list could contain repeats, so we need to get rid of them if they're not allowed. Okay, so this is quite a long line, but all this is a list comprehension where it's actually written in essentially plain English, which is fantastic. So we're just going to set the possible next tracks to be any track for all the tracks that are in the possible next tracks, if that track is not in the tour so far. So we're just going to remove duplicates. Okay, so we're now ready to actually make our tour and pick one of these next tracks as the track that's part of the tour. How do we do this? Well, the first thing we want to do is just randomize the order of the possible tracks. Okay, so by importing Python's random library, we can do this by simply shuffling up the list, random.shuffle. Okay, so for then every track that's in our possible set of next tracks, what are we going to do? We can instead see if we would be finished if we went to this track. Okay, so we're going to use recursion here to call the method that we're inside right now again. If we have the tour that we have already, which is our tour so far, and we add this next track, then we might get back a complete tour. Okay, and if this is not a complete tour, then this method will return nothing. As you can see, if it always fails and it runs back there and returns nothing, then we will just go on to the next track in our set of possible next tracks. We'll add that to our tour so far, and we'll be, okay, can this one complete now? Is it possible for this one to be finished? And again, we'll check if it's complete or not, and we'll leap through all of this until we've checked all of the next tracks we can get to from the track we're at right now by adding it to the set and going through this whole process again of checking if it's now long enough, and we return the whole thing. And if none of these tracks whatsoever work, then we know we've hit a complete dead end. So we wanted a tour of length 5, but currently we're at Boost Cinema and we've been to every single one of its neighbors already, and there's just nowhere else for us to be able to go because we're not allowing repeats. And it's just a complete dead end. Nothing can happen. It's not possible. And we just return nothing. We give up. Okay, so if we just run this now with a length of 2, you can see that it's generating us a new random tour of length 3 because we need 2 races to go in between these 3 tracks. Okay, and every time we run it, it's going to give us a new set of 3 tracks that we can race between, which is amazing. We still have loads more exciting features to add though, and the first one is this isn't really that user-friendly to see. If someone's come across this and they just get given this ugly little list with these numbers and the brackets, it doesn't look very nice. So let's print a better way of showing this tour to the user. Okay, so instead of just printing directly, we're going to call our print tour method, which is going to allow us to do some new fancy stuff. Okay, so the first thing we need to do is just make sure that this tour, if it's none, then obviously we can't do anything because no tour was found. But if a tour was found, first of all, let's just get the number of races so we can show that to the user. Okay, so here we have, you can see we're getting the length of the tour and we're taking 1 away from that to get the actual number of races that we have. And then we're just going to print out a string which has that number embedded in the string using the F string and the curly brace syntax here. And we're going to race custom tour. That's just what we're going to say. And now we can say we're saying a 2 race custom tour. Perfect. Okay, that's a good start. So for I and range races, so this is just going to be a counter for every race. So it's going to start with the first race and the second race, and then it's going to be done. We're going to get the starting and ending track of each of those races. Now, what was that? So just to help us, I'm going to add back in a print of the entire tour at the top. So you can see that the whole tour, the first one is Peach Stadium, Faraway Oasis, Cheap Cheap Falls. So this is going to start at 0. That's going to give us the starting track is tour 0, Peach Stadium, and 0 plus 1, 1, Faraway Oasis. Then this is going to run again with an I of 1, which is going to give us the starting track this time, Faraway Oasis, and the ending track of 1 plus 1, 2, Cheap Cheap Falls. And this gets printed out here, which is a much nicer way of displaying it, in my opinion, saying that we're going from Peach Stadium to Faraway Oasis, and then the next race we're going to go from Faraway Oasis to Cheap Cheap Falls. It still has the track dot before it. We're only printing out the tracks, we're not doing anything else, so we can still improve this. Okay, so we can say this is a 2 race custom tour, and the first race, given by the number of I here plus 1, gives Wario Stadium to Toad's Factory, which we're just getting the name here of the starting track and the name of the ending track. And then race 2 is Toad's Factory to Acorn Heights. And I think that looks a lot nicer, and this is a really good. You could just take this and use this, and you could, take a screenshot, print it out, do whatever, and you can use this. You could hand this to someone, and they would be able to do the races, which I think is really cool. Okay, so we can add a new setting here to allow 3 laps. Now, what does this mean? Well, in a situation where we don't want to allow repeat tracks, so for example, we don't want to go from Choco Mountain to Crown City to Desert Hills to Whistle Stop back to Crown City again. Now, currently we can't go back to Crown City again because the allow repeat is false. But if we allow for 3 laps, we would have wherever we were, Crown City again, wherever we go to after that. And in terms of the gameplay, this would be the same as picking Crown City on the Crown City menu instead of going somewhere else. And this gives us a new type of race. Okay, so we're going to be able to do this by just changing in the random tour of length code. When we're not allowing repeated tracks, we want to add an exception to potentially add the current track that we're at back into our list of possible tracks again, even though we've just removed it. Okay, so if we're allowing 3-lap tracks and the length of the tour is greater than 1, so that just means that we actually have a track that we can repeat, because if this is our first track, then we can't repeat nothing because we haven't even started yet. We're going to get the previous track. Okay, so the previous track is just the last track in our tour so far, and we can get that with the -1 index. We actually need to make sure it's also possible to do this 3-lap track, the self loop, which it is for every track other than Rainbow Road. Okay, and we can do this by just checking if the world has an edge from the previous track to itself. Okay, then in that stage, we can be confident we can add back in the previous track to the possible next tracks. So it's not guaranteed, but it could show up and we could get a 3-lap race. The only problem with this is that think, for example, that we've looped in Crown City, we've done one 3-lap race, fantastic. Then the next time we do this again, we're still at Crown City, so we come through here, we're still allowed 3 laps. The previous track, okay, that was Crown City can loop. And then, oh, we're going to add Crown City as a possible track again. At which point, if it's chosen, this is random, but it could still be chosen, we could have 2 3-lap tracks of Crown City in a row. Now, maybe you want this, but I think at that point that's a bit excessive. So we need to add a second check to make sure that we didn't just do that in the previous track. So we can only have a 3-lap track if we didn't just already do it. Okay, so one way we know we didn't just do a double 3-lap track is that the length of the tour is only 1, because you need 2 tracks in order to have done the 3-lap track already. So that's one case. Okay, and the other condition that it's okay is if the previous track is not the same as the previous track. If we just randomly generate tours for long enough, we'll come across one. And here, the first race, actually, we have Peach Stadium to Peach Stadium. So we're still not allowed back to a track once we've left it, but we can, if we're already there, just once, do a 3-lap track. Great. But of course, this can be improved as we're printing it out because we're not going from Peach Stadium to Peach Stadium, we're just staying at Peach Stadium. Okay, so we can make this a bit nicer in our printing tour code, where if we detect that the starting track and the ending track are the same, we're just going to say that that race doesn't start at the starting and end at the ending with a little arrow. We're just going to say we're doing this track for 3 laps. Okay, and here we go. This is one where on race 7, we go to DK Spaceport for 3 laps, and then obviously we leave it to Koopa Troopa Beach, and we got there through Crown City. There might just be some tracks that you really hate, and this happens to me too. Whistle Stop Summit isn't that great, if you're honest. So here we just have it, so these tracks will basically never appear in any of the tours that we generate. And we can do that by importing the tracks here into the settings file as well. Let's just, for example, give a track we don't like. Starview, not Peak. So how do we use this? Well, it's really simple. Just before we randomly shuffle the possible next tracks, we're just going to remove it if it's not one of the tracks we want. Okay, so we want the new list of possible tracks to be the list of tracks for every track that's in the possible next tracks, if that track is not in the list of excluded tracks. So it's a bit of a mouthful, but it's really nice and simple. We're just going to go through, and if it's in the included tracks, we're not including it. Then everything just carries on as normal. And I suppose this is kind of hard for me to prove to you, but hopefully you can see that those tracks that we've excluded are just never going to show up in our list anymore. So it does limit the amount of tours you can have, but if you just really hate some, then it doesn't matter. You can get rid of them, never see them again. Okay, but what if you're a bit more curious, and instead of just generating completely random tours of some length, you want to be able to have some slight control over it? Maybe you want to make a random tour that starts at your favorite track, starts at some track that you want to set, but you don't care where you end up. You just want to do some number of races from a position. So this is the method for generating a random tour from a starting track. And this one's actually incredibly easy. All we need to do is just call our random tour of length method, but just give it a tour so far of the starting track, where it means it's just always going to start from here, and we're going to end up wherever we end up. And let's just check this. Okay, so we're going to say we're going to go from Desert Hills, and every single tour that gets generated is going to go from Desert Hills. So Desert Hills, Desert Hills, Desert Hills. And you can see that the ending is different every time. This time it's Whistle Stop for 3 laps. This time it's Moo Moo Meadows. This time it's Shy Guy Bazaar. Anything here. But they always start from Desert Hills. Okay, so next, what if we want to always end at some track after some number of races? Okay, so this time we always want to end up at Desert Hills. And you might think everyone crazy. So right now, the random length of tour 2 is just going to give us the exact same thing as from. So obviously, this Desert Hills here is always going to be first, not last, which is what we want. So this is clearly not working correctly. But what about this? Okay, so we get that random tour of length that starts from our ending track, and then we just reverse it. What happens now? We can see now that we end at Desert Hills. We end at Desert Hills, we start at somewhere else, but we still end at Desert Hills, end at Desert Hills, end at Desert Hills. Now, this is almost perfect, and you might think, okay, great, we can stop. But there's a slight twist here. This way of doing this, the original tour would have been from Desert Hills to Shy Guy Bazaar. And you can only do this reverse here if, and this is a very big if, you can go from Shy Guy Bazaar back to Desert Hills. And this is almost always true, but let me give you an example where it's really obviously not. Okay, so here's where the logic falls apart. If I say I want to go to Peach Stadium and my logic is just simply going from Peach Stadium to somewhere random and then reversing it, well, that can give us a case where we go from Rainbow Road to Peach Stadium, which isn't true. You can't just always completely reverse these edges because you can't go back from Rainbow Road. Instead, what we need to do is we need to tell this random tour of length method that we're going backwards, and we can make one tiny change to make sure this still works. Okay, so we're going to set a new variable here, backwards equal to true, but it is of course false all the time, most of the time. It's only ever true in that new backwards method. And when we're coming down, here is the problem. So the possible next tracks, we're getting the successors. So for Peach Stadium, the successor is Rainbow Road, but Rainbow Road does not have the successor of Peach Stadium, which is the problem. Okay, so a new example. Let's say we want to end up at Rainbow Road. So if we run this right now, it's going to completely break because there is no tour that gets from anywhere to Rainbow Road and we're reversing it, but you can't reverse it because it doesn't exist. So this is even more broken. And let's look at the logic here. So we're trying to get the successors of Rainbow Road currently, which is nothing, so we can't go anywhere, and it just gives up. So what we need to do instead, we've given it, we want to go backwards, not forward. And the successors is kind of implying forward motion. It's saying, can we go from one edge in the direction of the arrow to the next track? Well, if we're going backwards, we want to do the exact opposite of that. We want to find all the nodes from this example from Rainbow Road that are pointing to us, which in this case is Peach Stadium. Not that we're pointing to, places that are pointing to us. Okay, so if we're not going backwards, we're going forward, we just want to do the same thing we always did. But if we are going backwards, what we want to do this time is get the predecessors. Now, obviously, successors is kind of going forward, predecessors is going backwards, and that does exactly what we want, which will mean that the Rainbow Road going backwards will actually work this time. Now, when we run this method, everything works great, and we can see that we're getting the predecessor of Rainbow Road, which is Peach Stadium. And then we're just going to reverse the same track. So we're still reversing the track, but we're actually making sure that the edge going backwards does exist. So when we reverse it, it's safe to do so. Okay, so that now gives us random tours of length 2. Let's make it a bit longer. And let's say we want to go to Rainbow Road. Then, okay, we're going to start at Acorn Heights this time for 3 laps. Toad's Factory, Peach Stadium, Rainbow Road. Amazing. So saving the more challenging one for last is going from a position to another position. The reason this is challenging is that because we want everything to be random, we can't just find some shortest path algorithm between the two places. Not only because it would be the same all the time, but also because we don't want it to always to be the shortest path. We want any path of any length we give. And the randomness really throws things off here. It makes things a bit silly because there is a very silly answer to this question. Okay, so the really silly way of doing this is if we want to go from somewhere and to somewhere else, well, we already have methods to go from and to separately. So if we just use one of them to generate a tour of the right length from a starting track, we get that tour, and then we just check if that tour is valid. Now, by valid, we're just going to say that we actually found a tour because sometimes it can fail. The example with Rainbow Road to somewhere else, for example. Then we just want to check the tour has the correct length, just to be absolutely certain. And then we just want to double check that the starting position of the tour is the track we want and the ending position of the track is what we want. That's the only one that's actually in question, really, because all these other 3 should be guaranteed. But this is a random tour from the starting track, and we're just going to hope randomly that it just happened to end at the ending track. And we're going to try a million times. If we keep failing over and over again, we'll just keep looping and looping until we find one that's valid that we will return. Now, if we don't find one in a million attempts, then we just give up. And honestly, I would give up too after trying that long, because this is a very silly method, but it does work. For example, we can pick 2 tracks on way of the other end of the map. So we have Shogo Bazaar over on one side, Sky High Sunday on the other. And let's say I want a tour of length 8. I want to do a big, massive tour from one side of the world to the other. Well, we can do that. We can go from Shogo Bazaar, and it didn't take that long. You wouldn't have even noticed that it did this randomly. And it goes from Shogo Bazaar, it goes blah, 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 through all the tracks, and it ends back at Sky High Sunday. So this method does work, and if you just want a working solution, then that's completely fine. You can pretty much just stop right here. But I'm going to show you how to actually do this, and it is so much better. So if we want to be able to go from track A to track B, going from A to B, there has to be some track C in the middle where you can go from A to C and you can go from C to B. How does this idea help us? Well, instead of just generating one random tour here, let's generate two. Okay, so tour AC is now guaranteed to go from our starting track to anywhere. We don't know where, but let's just call it C, somewhere in the middle. Then we have another tour now, tour CB, which is going to go to the ending track. It's going to end at track B, our ending track. Now you can see, obviously, if we could somehow combine these to be tour ACB, then that would go from A to B through C. Okay, so the general structure we want is that we're going to create this new tour, ACB, by merging the previous two tours, by finding that C in the middle. And then if we find it, then we're just going to return it. So the real meat of this now just comes down to how we want to merge these tours. Okay, so the first obvious thing we need to check for is that one of these tours could be none, one of them could have failed. So if either of them is nothing, then we just return the other one, because you can't merge something with nothing, so we just return the something that we have. Okay, so if we've made it here, then we do have two tours of the same length that we can try and merge. And how do we want to do that? So surprisingly, these three lines are all we need to merge it, and it's really surprisingly powerful what these three lines can do. So I've made the tour a little shorter just so we can see it all on the screen here. Okay, so just by printing out whenever this works, we can see what's going on. Then the first line is the tour AC, so that's starting at Shy Guy Bazaar, which is where we want. And this tour, Sky High Sunday, ends at the place we want. We couldn't just randomly chop them in half and stick the ends together because the two tracks next to each other might not go together. But what we can do in this case is we can see that at K, which is 1 here, that they're the same. And this is indicated by at position 1, these Choco Mountain tracks are the same. So what we could do, which would be a valid tour from Shy Guy Bazaar to Sky High Sunday, is to take this part of this tour to go from Shy Guy Bazaar to Choco Mountain. Then you can see that this Choco Mountain, Cheap Cheap Fool, Sky High Sunday, is that part of that tour. Now then all we need to do is just take the Shy Guy Bazaar part of this tour, which is what this line does here up to K, and we want to take the Choco Mountain, Cheap Cheap Fools, and Shy Guy Bazaar part of this tour using this code here, which we can do because we're already at Choco Mountain in this tour. So just we ignore going to Toad's Factory, we go to Cheap Cheap Fools instead, and then we can continue on to Sky High Sunday. Okay, so another example, if we want to go from Bowser's Castle to Dino Dino Jungle in 5 tracks, that okay, the first tour it found from Bowser's Castle goes all the way, blah, 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 blah. And this time it ends at Peach Beach, which is not what we want. But you can see here on track 3, Starview Peak is here. Well then, and also the tour that we found that ends up at Dino Dino Jungle, which is where we want to go, that also has a track 3 of Starview Peak. So we can take the first half of this tour here, which is Bowser's Castle to Mario Circuit, and then instead of carrying on, we can switch down to this part of the tour to go from Starview Peak, which we were at anyway, Sky High Sunday Salty Speedway to Dino Dino Jungle. So that's how the merging works, and it makes us guaranteed that we will have a safe path from one place to the other. Okay, and because it's relatively cheap to check if the tour is valid compared to trying to merge, it might just so happen by pure luck, the same way that we had for our silly method earlier, that the tour we generate randomly from or randomly to one of these positions does actually just work. So we might as well check for these to just if they just happen to be right away. But if they're not, which is much more likely, then we try and merge, which is a much higher likelihood of these being able to be combined instead of one of them individually being correct. And if you're interested, I ran some numbers, and the silly method took on average over 1,000 attempts for all the different sizes of tours we can have, about 20, high 20s to low 30s number of attempts. Whereas when we allowed merging, now, obviously, merging is a lot harder when the tours are short because there's less tracks you could potentially merge on, but it's still much faster. And as the tours get longer, you're almost guaranteed to be able to find some merge point as the tours get longer, which is amazing. We can get 1s and 2s. And even though you're generating 2 tours per every time you run this better method, so this is really 14 and 12, it's still much better than the silly random algorithm. And this is obviously the same if you're going to tracks that are further away. The difference is even greater. It's so much better. Okay, so now we have the ability to generate our random tours of a given length to or from some track. We want to be able to visually show this to the user in a way that's a lot easier to understand. And you can see the graphic that we're going to create. I've called this a poster. So let's create a new file so we can make these posters. Okay, so we're going to start very simply by just importing everything from our tour creation file and just creating a tour here and printing it out just to check that everything still works. Okay, so the first thing we need to do, in order to create these images, we need to somehow define them in code first and then save them to a file. Okay, so we're going to use a new library called Pygame, which is the go-to library for creating games in Python, but it also has a really nice surface system, which you can draw anything to and use without the game part, and just use it to create and save images. So what are we doing here? We're creating a Pygame surface 500 by 500, and then we're just simply saving that to a file. And if we open this file, you can see it's just a completely blank empty surface 500 by 500. Now what is a surface? I think of them literally just as like a blank art canvas. It's just the sheet of paper that you draw on, and you can add anything to it. You can add other surfaces inside other surfaces. You can fill them with colors and shapes and whatever you like, but the surface is just the actual canvas that you draw on. Okay, so for example, if I just wanted to make the surface completely red, then I can fill the surface with my color red, and we'll refresh this, and you can see, okay, the image is now red. But we want a surface, instead of 500 by 500, to be the same size as the background image, so we can then draw the tours on top of it and then save it back out again. So unfortunately I can't just include all these images because the Nintendo Ninjas will show up at my house. So after finding those images, whichever ones you like, we now have a background image in our product directory, and we also have a new folder for the track icons, which just has Cheap Cheap Falls, Great Question Block Ruins, the icons for all of those. Okay, so what we need to do now is load in the background image, get its size, and then create a surface of that size. Okay, so how do we do that? Well, we can use pygame.image.load this background image, which we can see here. Then we get the rect of the background image. What is the rect of a background image? Well, this is the rectangle that would fit around your image, and it would start with 0, 0 in one of the corners and the width and height size on the other corner. Then instead of giving this surface 500 by 500, we now give it the actual background rect's size, and then we fill it with red in the same way. And you can see that these are the exact same size now, which is perfect. Okay, so what we can do now is we can add this background image back into our surface. Okay, and we add the background image to the surface that we're saving to our file by calling surface.blip and then the surface that we want to add, which is our image. So these are both surfaces, and you can add one surface to another using .blip. Then this background.rect just says where do we want the background to go on the surface. So we could also give it a different place to go to. So this would be 0, 0, which is just the origin, so you can't really see any difference. But we could make this much more drastic. Okay, so we could put the background in position 100, 100, which is here, which you can see, okay, well now we still have the red background behind this because the image is no longer in where it should be. But if we just go back to as it should be now, we can also get rid of filling this with red because it's just not needed anymore. Okay, and we have our background. Okay, so now we have our background image. We want to be able to just add the track icons to it. So let's just pick one of these and do just that. Okay, so we can load the image in from a path. First of all, we need to define that path by going into our track icons folder and then getting the image which has the same name as the track that we want. Then we ask Pygame to load that by just using Pygame image load the same way as we did with the background. Okay, so now let's just load one, for example. Okay, and let's just put it right in the top left of our surface. Okay, and you can see now that if we just make this a bit bigger, you can see Peach Beach right in the top left here, which is fantastic. Okay, if we wanted to put this somewhere else, for example, we could move it over a little bit, and you can see this now jumps over. Okay, so one thing is going to be important to do at this stage is that because there are so many different files here, we might have just called one of them incorrectly and it would break. Let's write a little function to just make sure we have everything we need. Okay, so this is obviously bad code, really, because if there's a problem, this is going to throw an error, but that's fine. That's all we want to see. So we can run this. It's kind of very bad and hacky, but it will get the job done. And we're just going to try and load the image for every single track. And if we run this, oh, we can see we actually have a problem. No file, track icons, faraway oasis not found. And why is that? Okay, oh, we can see here my faraway oasis icon is actually called faraway oasis. So we can rename this to what it should be, faraway oasis. And now let's run this again. Okay, and now it ran correctly with no problems, so we can confidently just delete this code again, and we know that we have the icons that we wanted. Okay, but right now we're still only putting our track icons in just this random position here. Where do we actually want to put them? And I think a good thing to do here is we want to define a rectangle inside our image of which all the track icons are going to fit. Basically just so we have some padding around the edges where there's no track icons, just to kind of make it look a bit nicer than them being right at the edges, which never looks very good. Okay, so what are we doing here? We're creating a new rectangle, and this is the rectangle that's going to contain all of our tracks. And it's just simply a rectangle, a position. We don't care about the position right now, we'll do that later, but its width and its height are going to be defined as the same as the background minus some little inset here. And let's visualize this. Okay, so we're going to draw onto our surface this rectangle in black. And you can see that it just kind of shows up here. And we don't want the tracks to go here. We do want them to be inside this rectangle, but obviously we need to move this rectangle to the center. Okay, and we can do this really easily by just getting the center of our background rectangle and just making that the same as the track rectangle. And it's now centered. Okay, so now we want to draw the icons. First thing we need to do, of course, is to see how big we want the icons to be. Okay, so we know the length of our tour represents how many tracks we have. So if we just divide the total width of this rectangle by the amount of tracks we have, we'll be able to fit all of our tracks one by one after the next along this rectangle. The only problem right now, though, is that when we're loading in these track icons, we're not actually making them be this size. So let's add a size parameter to ensure that all the icons that we're loading are the correct size. Okay, so we can do that by passing pygame.transform.scale, giving it our icon, and we can make it the size that we gave it. And because it's a square, we can just make both dimensions the same here with one parameter for the size. Okay, so now let's actually draw our tracks. Okay, so to just check we're doing things correctly, we're going to go through every index of our tour, get the track, and just print it out. So you can see here we've got Dandelion Depths, Toad's Factory, Bowser Castle, Choco Mountain, Crown City, which are the ones that we have here correctly being printed, so that's okay. Okay, then for each one of these, we're going to load the icon by using the method that we defined before. Okay, so just like with the background, we're also going to get the rectangle that goes around our icons, and we're going to draw the icon on the surface in this position. So you can see right now it's just going to go right in the top left. But of course, we want these icons to actually go on the left of our little black box here. Okay, so we can do that by once we've got the rectangle, we set the center Y position to the track center Y position, which puts it horizontally along this line. And then we're going to put the left-hand side of the icon to be the same as the left-hand side of this track box, which is why it's now over here instead of being way over on the left-hand side. But of course, we have the problem of all of the tracks, every time we run this, are put in the same place, which isn't very helpful. What we need to be doing, instead of always putting the left-hand side to be the track's left position, we need to make this left position change depending on which icon we're drawing. Okay, so we define a new variable just left here, which is going to start as the tracks rect.left, and then we use it here, which is the exact same as before. They're all now drawn on the left. But what we're going to change now is that after we've drawn the first icon, we're going to change the new left position for the next icon to be this icon's right side. And then if we run this, we can see that the icons are now all equally spaced out. And now we're confident that it's working and the layout is correct. I think we can get rid of our black rectangle here because it's not very nice. This unfortunately introduces another problem where you can actually kind of not see the track icons very well over this background image. And the way I solved this before is just adding a blue circle around the back of all these icons just so they pop a little bit more. You can kind of do anything you want here. This is just an example. Okay, so what do? We define a color for the circle that we want, define a size of the circle that we want behind the icon, and then we just draw the circle with draw circle onto the surface in that color. The position, the center of the circle, we want that to be the same as the center of the icon, and then we just want to do the radius here for how big the circle is going to be. Let's see this. Okay, so clearly this radius is far too big. Even that's still a bit big. Personally, okay, I don't mind 0.3, I think that looks quite nice. We can see, however, that I've tried to give this some transparency. We have the RGB values of our color as normal, but we're also setting the A value of the color, which is supposed to be the transparency, it's alpha level, where 255 would be just completely opaque and normal, and 0 would be completely transparent, invisible. So we're somewhere in between, but we should still be able to see the background of the map behind it, which we can't. And I'm not entirely sure why we need to do this, but in order to get the transparency, instead of drawing directly to the surface, we need to create a new surface for the circle, which is transparent, and then put that surface onto our current surface. Okay, so we can take all of this code. Okay, so let's move it up here. So just after we calculate the icon size, but before we're drawing any of the tracks, let's create this new circle surface. This circle's surface has the size of the same size as the icon because of course we want it to go behind the icon. So the center of that is just dividing by 2 to get the midpoint. Then the radius of the circle stays the same and we draw the circle in the same way as well. Okay, so now just before we draw the icon, we can draw the circle's surface in the same position as this icon. And we do it first just so the track icon then gets put on top of the circle, otherwise it would get overlapped. Okay, so what the hell's gone wrong here? So we do have our blue circles, which is fantastic, but they're still not transparent. And we have this massive black box around again, which is not the black box that actually shows us where the tracks we want to go are, because that's this color here, which is commented out. But we can see more clearly what's going on if we do one small change. Okay, so before we draw the circle, we're just going to fill the entire surface with green. And okay, now you can see what's going on. Is that although we've only drawn a circle in the circle surface, by default, as we saw before, surfaces are just completely black. And now we fill it with green, the surface is just completely green, and it's still a square. So these are all just individual squares around the circles, which are just being filled with green, which is obviously not what we want. And if we go back to this, although these are being shown as black, it's really just because there's nothing there because we've only drawn the circle. And the way we can make Pygame interpret this black, this nothing, literally nothing in these pixels, to be transparent is to just pass that as a parameter to our surface. Okay, so this pygame.sourceAlpha just tells Pygame to consider this surface as something that we're using the alpha channel for. Okay, we run this now, and perfect. So the circle where we're not drawing is just completely empty now, and the circle itself, its color, it's finally using its transparency, and you can still slightly see through. If I zoom in, we can actually see through the circles now. Amazing. Okay, all that's left to do now is to draw the road from one track to the next. Okay, so each line that we're going to draw is going to start from the X and Y position of the rect. So right in the center of Bowser's Castle here is where the line is going to start. Okay, so the end point of this line is going to be wherever we started from, so over here at Bowser's Castle, and we're going to add one icon's widthways to go over here to get into the center of Toad's factory. Then the end Y is just the same because the Y coordinate's not changing, we're still just going horizontally along this line here. Okay, and finally, we're just going to use our pygame.draw method once again, this time for a line. We're going to draw onto our surface in black. Well, very roughly we can see, maybe YouTube compression is going to kill it, but there is a very, very faint 1 pixel wide line here. So we need to make it slightly wider. Okay, so for me, width of 15 seems roughly pretty good. I kind of like that. One problem that we do have though is that the line is being drawn on top of the track icon, and I think it should go behind. So what we can do is take our surface.blit of the icon here, copy this, and just move it down to after we're drawing our line. Okay, and now the track icon is on top of it, which is brilliant. We also have another problem though, is that the Peaches Stadium, it doesn't know that this is the last track, and it's also drawing a connection line to the next track, which doesn't come. So it just kind of goes off the end, which is definitely not what we want. Okay, and we can stop this happening by only drawing the line if the index that we're currently at, so which track we're on, is less than the number of tracks -1. Now, why do we need the -1? Well, basically it's because the indices go from 0 to the length of the list -1, because if we had 5 elements here, 1, 2, 3, 4, 5, the indexing is 0, 1, 2, 3, 4 in the list, so 4 should not draw a line outwards, and we have 5 things. So this number of tracks is 5, minus that one is 4. So for any track which is before 4, we'll draw the line, draw the line, draw the line, draw the line. This one, however, this one's 4, which is number of tracks -1. So we don't want to draw the line this time. And there we go. Okay, so in my version of this, I have also made it so there's a little grey and white line going through the road as well, just to make it a little bit more road-like. And also changing the colour to indicate when something is an intermission track versus when we're just looping on the same track. But I think I'm going to leave doing those things to you just to make sure you've understood and taken this in and give it as a little bit of a challenge. But if you want to see the code, of course, you'll be able to do that with the link in the description. Okay, that's everything I can think of for this series. I've absolutely loved making it, so thank you so much for sticking to the end. I hope you've enjoyed this product and it will let you enjoy playing Mario Kart World for years to come. I know it is for me already, I'm loving it. But much more importantly than that is that you stay curious, everyone. See you next time. Bye bye.